Alright, welcome back everybody. So today we are going to explore more with an arithmetic series. Okay, so in algebra class, there's a good chance you've maybe talked about something called a sequence, or an arithmetic sequence. So today we're going to take it a step further and talk about an arithmetic series. So before we do that, let's just go ahead and recap what an arithmetic sequence is. So this is a sequence of numbers. It's just a list of numbers. 2, 5, 8, 11, and then in your algebra class, maybe you've talked about how would you find like the 30th term in this sequence. Okay, so first of all, what makes it arithmetic? So what makes this arithmetic is, if you notice, we're adding the same number each time, plus 3, plus 3, plus 3. So that's what makes it arithmetic. So to find the 30th term, so your teacher maybe had you make a table in Desmos and find an equation that would match this. But there's a formula that we can use to find the 30th term, and it looks something like this. We use this notation, a with the subscript n. So to find the nth term, we take the first term plus the common difference, so we use letter D, times n minus 1. Okay, so just to kind of clarify what do all these pieces of this puzzle mean. So A1 means the first term. D is the common difference. The common difference is the number that we are adding or subtracting by every time. And then N is the number of terms that we're trying to find. Okay, so if I was going to find the 30th term, so we would do A with the subscript 30. We use the first term, which is 2, plus the common difference, which is 3. We're adding 3 each time, and we're trying to find the 30th term, so we would do 30 minus 1. Okay, and we could throw this into Desmos and calculate this. So this would be 2 plus, so 3 times 29, which would be 87. 2 plus 87 would be 89, and so we'd find out that 89th term in this, or the 30th term in this sequence is 89. Okay, so that's step one. Step one is to be able to find those terms using the formula. If you used Desmos before, we're going to need this formula today, so maybe jot that down as you're taking a look. All right, so let me clear this screen, and then we'll talk about what an arithmetic series is. Okay, so an arithmetic sequence, that's when we have a list of numbers, and those numbers are all increasing by the same amount that we're adding or subtracting that amount over and over. Okay, so now we're going to talk about an arithmetic series. So a series is when we take that arithmetic sequence, and instead of just listing them, now we're going to add those numbers together. So if we look from 2 to 5, that's still going up by 3. From 5 to 8, that's going up by 3. 8 to 11, that's going up by 3. So it's still arithmetic, because the numbers are increasing by the same amount. But now instead of just listing them, now we want to add all of them together. So that's what makes this a series, is that we're adding them. So in a second, we're going to solve this, but the question is going to be like, find the sum of the first 30 terms. Okay, so it's not just finding the 30th term, but adding all 30 of those terms together. So how are we supposed to do that? Okay, so to do that, we're going to look at the most popular example of this. So the most popular example of this, there's a story about a famous mathematician that was bored in his math class one day, and so his teacher said, why don't you try to find the sum of all the numbers from 1 to 100? Just trying to keep him busy. And he did, and he did it way too fast, and his teacher was like, wow, how'd you do that? And so here's how he did that. So if we want to find the sum of all the numbers from 1 to 100, so what this mathematician did is he noticed a pattern. He said, well, if I look at the first number and the last number, if I add those numbers together, that's equal to 101. And if I add this second and this second to the last number together, that equals 101. If I add the third and the third to last number together, that equals 101. And I could continue doing that until I got into the middle. until it was 50 plus 51, and that would be equal to 101. And so he found a pattern, and the pattern was I could take the first number plus the last number, and I can make a bunch of groups of 101. And how many groups of 101 could I make? Well, there's 100 numbers, and I'm creating groups of 2, so it would be 100 divided by 2, so it's 50 groups of 101, and when I multiply that together, I get 5,050. So this is the sum of the first 100 terms, 1 through 100. Okay, so if you look at this, there's a formula that we're developing here, where we take the first term, which is 1, plus the last term, which is 100, and then we want to know the number of terms. We have 100 terms and divided that by 2. And so the formula to find the sum of the first n terms of an arithmetic series is n over 2 times the first term, a1, plus the last term, an. And so this would be a good formula to write down too. So the number of terms divided by 2 times the first term plus the last term. And then the other formula that we talked about earlier that would be good to write down is if we want to find just the nth term, we would take the first term plus the common difference times n minus 1. So go ahead and write these two formulas down, because we're going to use these to find some of these values here in a minute. Okay, so if you look, we can actually kind of combine these two formulas, because if you look at this, the formula for the sum, our second formula for to finding the nth term of a sequence, those are the same thing, right? The nth term of a sequence lives in the formula to find the sum. So what we can do to kind of help clean this up, we can actually do some substitution. We could substitute our second formula into the first formula. And so if we do that, this would be the sum of the first n terms is n over 2 times the first term plus all of this stuff that we just circled, which would be the first term plus common difference times n minus 1. Okay, and if we look, we actually could combine these like terms, and so the most simplified version of this would be, this is a1 plus a1, this is 2 times a1 plus the common difference times n minus 1. Okay, so this would be another way we could write this formula. So if you want to jot this down, this would be great. So what do we need if we want to find the sum of these formulas? Well, we need n. N is the number of terms that we're looking for. We need a1. a1 is the first term in that sequence. And we need d. d represents the common difference. And so if we have these three things, we can use our formula to find the sum of however many terms we're looking for. Okay, so let's do some examples. Okay, so here's the first example I want to look at. It says find the sum of the first 20 terms of the sequence 2, 5, 8, 11, so on. Okay, so we're trying to find the sum. So this is a series problem. So we're going to use our formula that we have written down here. So what do we need? We need the number of terms. So our notation would be S with a subscript of 20. We're trying to find the first 20 terms. So N is 20 divided by 2, and then 2 times our first term, A1, so our first term is 2, plus our common difference. So this is 2, 5, 8, 11, so they're going up by 3. So our common difference is 3. We're trying to find 20 terms, so 20 minus 1. Okay, and then we can either just throw that into Desmos, or maybe clean this up a little bit. 20 divided by 2 is 10, 2 times 2 is 4. This would be 3 times 19, which is 57. So 4 plus 57 is 61, times 10 is 610. Okay, so the first 20 terms, if I did 2 plus 5 plus 8 plus 11 plus 14 plus 17 plus blah, 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 all the way until the first 20 terms, if I added all those up, then I would get 610. Okay, all right, that wasn't so bad. Let's do one more, and then we'll wrap this up. All right, so this one says, find the sum of the first 30 terms of the sequence where the second term is 24 and the common difference is 2. All right, so instead of giving us the first term and the common difference, now they're giving us some different information, okay? So sum of the first 30 terms, so 30 that's n, they're giving me that. They're giving me the common difference, that's d, so we know that. So what we're missing is we don't know what is the first term. So the second term is 24, but we really need to know the first term if we're going to use this formula. So that's not so bad, right? If we know the second term is 24, and we really need to know the first term, a1, well, working backwards, we know the common difference says what number should I add each time, plus 2 plus 2. So to work backwards, we would just do a little minus 2 instead. And so we can use that strategy to figure out that my first term is 22. Okay? So now I'm ready to go. Now I'm ready to use my formula. So to use my formula, I know I'm looking for the sum of the first 30 terms. Now I'm looking for 30, so n is 30 like we said. The first term now we know is 22, so my formula says 2 times 22 plus common difference, which is 2, times n. N is 30 minus 1. And again, we could throw that into Desmos, or we could try to simplify this by hand a little bit. This would be 15. 2 times 22 is 44. This would be 2 times 29, which is 58. And then we can do 58 plus 44, and then multiply that by 15. Let's just go ahead and use the calculator to help us out with that. So 15 times 44 plus 58. That gives us 1,530. Okay. So, good luck on your worksheet today. If you need help, feel free to stop and talk to your algebra teacher. But hopefully you enjoyed learning more about arithmetic series today.